Hello class! Today we're going to look at transformations of sinusoidal functions. So let's recall what a function looks like. The general form of a function is y equals f of x. In this unit you are learning the sinusoidal functions. One of them is y equals sine of x. The other is y equals cos of x. So before we start trying to transform these two functions, let's first remember what it's like to transform the general function, y equals f of x. So here is the general form of a transformed function, f of x. So f of x has been transformed by four different types of transformations. The first one is when we have a value in front of the function, a value that we'll call a, and that tells me that there's a vertical stretch or compression by the factor of a. The other transformation we have here is b. This b is inside the function f of x, but is factored outside of the x. And this b value tells me the value for the horizontal stretch or compression. If you remember, this one lies to you. So if you see the function f at 1/2 x, that really tells me that instead of a compression by half, it's really a stretch, a horizontal stretch by a factor of 2. The next transformation is this h. The h is still inside of the function f of x. It's next to the x, but the b factor is still factored outside of the h. And this h tells you whether or not there's a horizontal translation. And remember, this one also lies to you. So if you see the function x minus 2, instead of a left by 2, it's really a translation right by 2 units. The last transformation is the k, and the k is outside of the function f of x. It's attached at the end, and this value tells you the vertical translation. So there we have, if you remember, the general form of a transformed function. So now let's apply that to the sinusoidal functions. The first sinusoidal function is the sine function, which is y equals sine of x. So if we apply the first transformation, we should have a value of a. And that value of a will tell me that there is a vertical stretch and compression. The second transformation is the b value. And that one is inside the function, so it's inside of sine, but it is outside of the x. So we factor the b outside of the x but inside of sine. And this tells me that there is a horizontal stretch or compression. The third transformation, if you recall, is the minus h. Next to the x, the b is still factored outside the h and still inside the function. And that tells me that there is a horizontal translation. The final transformation is this plus k, and it is outside of the function of sine of x. So it's just attached at the end. And that tells me that there is a vertical translation. So now we have the general form of a transformed sine function. So let's move on to the cosine function. So if you recall, the general parent cosine function just looks like y equals cos of x. And so now we need to apply those four transformations. The first one is the a value in front of the function, so it's a in front of cos. And that tells you that there is a vertical stretch or compression. The second transformation is now inside of the function. So it's inside of cos, which is b, and it's still factored outside of x. So this b value tells you that there is a horizontal stretch and compression. So now the third one is the one next to the x, and that's the minus h. And that tells me that there is a horizontal translation. So remember, this h is next to the x, the b is factored out, but still all contained in the cosine. The last transformation is this plus k, which is outside of the cos function. And that tells me the value of the vertical translation. So here we have the general form of the cosine transformed function. Now these two functions look the same except for the sine and cos, but the same properties of the transformations are in the same locations. So keep that in mind as you work through the problems. Have fun!